Okay, so we're diving into some pretty fascinating research today, folks. We've had a lot of listeners asking about ivermectin and cancer, so we're going to take a deep dive into that.
Yeah, it's definitely a hot topic right now.
We're going to be looking at the latest scientific studies, and trust me, there's some really intriguing stuff out there.
Absolutely.
But before we get started, I just want to be super clear. This is for informational purposes only. Okay?
Great. Super
And
important.
we're not doctors.
No.
So definitely don't take this as medical advice. Always, always talk to your healthcare provider for any health concerns you might have.
For sure.
All right, now that we've got that out of the way, let's talk ivermectin. I think most people probably know this drug as an antiparasitic.
Mm-hmm.
It's been used to treat things like river blindness and scabies for decades.
Yeah, and it's actually got a pretty impressive history. The scientists who discovered it, Satoshi Mura and William C. Campbell, they actually won a Nobel Prize for their work back in 1978.
A Nobel Prize. Wow, that's pretty big.
Yeah, it's a testament to how impactful this drug has been in treating parasitic infections worldwide.
So how did we go from deworming to, potentially treating cancer? What sparked this whole new avenue of research?
Well, it's still early days in the research, but there's a growing body of evidence that suggests ivermectin might have some anti-cancer properties.
Anti-cancer properties. That's amazing.
Yeah, and what's particularly interesting is the range of cancers that researchers are looking at. We're talking breast cancer, colorectal cancer, ovarian cancer, melanoma, leukemia, and the list goes on.
Wow, so it's not just limited to one or two types of cancer.
Exactly. They're investigating its potential across a really wide spectrum of cancers.
Okay, so what kind of studies are they doing? Are we talking about like test tube studies, or are they actually testing this in living beings?
Well, they're doing both. They're looking at its effects in vitro, which means in the lab, like you said, with cells in Petri dishes.
Okay.
But they're also doing in vivo studies, which means testing it in living organisms like mice.
So they're seeing how ivermectin actually behaves in a living body.
Exactly. And the results from some of these studies have been really promising.
Like what? What kind of effects are they seeing?
Well, one of the areas that researchers are really excited about is cell motility.
Cell motility, what's that?
Okay, so think about how cancer spreads. One of the big problems with cancer is that the cells can break away from the original tumor and travel to other parts of the body.
Right, that's how cancer spreads.
Exactly, that's metastasis. And what some studies have shown is that ivermectin can actually inhibit the migration of cancer cells.
Wait, so it's like it's stopping those cancer cells from moving around and spreading.
Yeah, that's the idea. There was one study where they looked at colorectal cancer cells, and they found that ivermectin was able to stop those cells from migrating, even at concentrations that didn't affect the growth of normal, healthy cells.
So it's like it was selectively targeting the cancer cells while leaving the healthy cells alone.
That's what it looks like. And they saw this effect not just in vitro, but also in vivo. They injected mice with colorectal cancer cells and then treated some of them with ivermectin. The mice that got the ivermectin had significantly fewer and smaller metastatic tumors compared to the mice that didn't get the treatment.
Wow, that's impressive. So it's not just a theory, they're actually seeing it work in living creatures.
Yeah, which is really exciting.
So how does it actually work? Like on a molecular level, what is ivermectin doing to stop those cancer cells in their tracks?
Well, that's where things get a little bit more complex, but really interesting. Researchers believe that ivermectin is targeting a specific pathway that's involved in metastasis. It's called the β-catenin integrin 1-A pathway.
Whoa, hold on a second. That's a mouthful.
Yeah, no, it's a long name. But basically, think of it like this. It's a chain reaction that happens inside the cell. One molecule activates another, and then that activates another, and so on.
Okay, so it's like a domino effect.
Exactly. And this particular pathway, the WNT pathway for short, is really important for things like cell movement, adhesion, and communication. And in a lot of cancers, this pathway is overactive, like someone cranked up the volume way too high.
Oh, I see. So it's like the cancer cells are getting all these signals to grow and spread uncontrollably.
Exactly. And what ivermectin seems to be doing is inhibiting this pathway. It's like it's putting the brakes on those cellular processes, especially the ones that are driving metastasis. In that study with the colorectal cancer cells we talked about, they found that ivermectin was actually suppressing the expression of certain proteins that are key for cancer cell migration.
So it's like ivermectin is cutting off the fuel supply for those metastatic cancer cells, preventing them from spreading.
That's a great way to put it. And it's not just about disrupting movement. There's also research suggesting that ivermectin might be able to enhance the effectiveness of traditional chemotherapy drugs, like cisplatin and paclitaxel.
So it's like a power-up for chemo.
Exactly. By combining ivermectin with these drugs, researchers are hoping to achieve even better outcomes for patients. And there's more. Ivermectin also seems to impact a key enzyme called PAK1.
PAK1, what's that?
Well, PAK1 is an enzyme that's often overactive in cancer cells. And research suggests that ivermectin might inhibit PAK1, which could be another way it's fighting cancer.
Wow, so it's like ivermectin is this multi-pronged attack on cancer cells. It's blocking their escape routes, cutting off their fuel supply, and weakening their defenses.
That's a really good analogy. And there's even more. It seems that ivermectin can trigger different forms of programmed cell death in cancer cells.
Programmed cell death, that sounds intense.
Yeah, so programmed cell death, also known as apoptosis, is a natural process in the body. It's basically a way for the body to get rid of cells that are old, damaged, or no longer needed. It's like the body's built-in cleanup crew.
Okay, so it's like a controlled demolition of those unwanted cells.
Exactly. And what's interesting is that ivermectin appears to be able to trigger different types of programmed cell death in cancer cells, including apoptosis, autophagy, and possibly even paroptosis. Each of these processes has its own unique characteristics and mechanisms, which adds another layer of complexity to ivermectin's potential anti-cancer effects.
Wow, this is absolutely fascinating. It sounds like ivermectin is a real contender in the fight against cancer. But I'm sure there's still a lot we don't know, right?
You're absolutely right. There's still a lot to learn. Oh, yeah, there are definitely still a lot of unknowns. I mean, this is a really exciting area of research, but it's important to remember that it's still relatively new.
Right. So what are some of the big questions that researchers are still trying to answer? Like, what are the next steps in this whole ivermectin and cancer thing?
Well, one of the key challenges is figuring out the dosage, We talked about how ivermectin is used to treat parasites, but the dosages for cancer treatment would likely need to be much higher.
Well, that makes sense. So it's not just a matter of popping a couple of horse pills and calling it a day.
Exactly. And obviously, higher doses could mean a greater risk of side effects, so it's really important to figure out the safest and most effective dose ranges for different types of cancer.
Yeah, safety first, for sure. So aside from the dosage, what else are researchers focusing on?
Well, another big one is understanding the long-term effects of using ivermectin, especially at these potentially higher doses. We know it's generally considered safe for short-term use at the dosages used for parasitic infections, but we need more data on what happens when people take it for longer periods and at higher levels.
Right, so it's all about weighing the benefits against the risks.
Exactly. And then there's the whole question of how ivermectin might interact with other cancer treatments. I mean, we touched on how it might enhance the effectiveness of chemotherapy, but there's a whole universe of possibilities to explore there.
Yeah, like what happens when you combine it with radiation therapy or immunotherapy?
Exactly. There's a ton of research to be done on how ivermectin fits into the bigger picture of cancer treatment.
It sounds like there's a lot of potential, but also a lot of unknowns.
Absolutely. And let's not forget about the challenge of delivery. Getting the ivermectin to the cancer cells effectively. Some tumors have barriers that make it difficult for drugs to penetrate. So researchers are working on developing new ways to deliver ivermectin more efficiently, like maybe using nanoparticles or other targeted delivery systems.
So it's like a targeted missile system zeroing in on those cancer cells.
Yeah, that's the idea.
It's pretty amazing stuff. But even with all these challenges, it seems like the potential benefits of ivermectin in cancer treatment are pretty significant.
Oh, they definitely are. And the research we've discussed so far is just the tip of the iceberg, really. There's so much more to explore. For instance, remember we briefly mentioned cancer stem cells earlier?
Those were the supervillains of the cancer world, right?
Exactly. They're like the masterminds behind tumor growth and recurrence. They're really tough to kill, and they can make it super difficult to achieve long-term remission.
Yeah, they sound pretty scary. But is there any hope that ivermectin might be able to target these cancer stem cells?
Well, early research suggests that it might. Some studies have indicated that ivermectin could potentially inhibit these cancer stem cells, which could really reduce the chances of the cancer coming back.
Wow, that would be huge. Imagine a treatment that could not only shrink tumors, but also prevent them from returning. That would be incredible.
It would be a game changer for sure. And then there's the issue of multi-drug resistance. You know how cancer cells can be really adaptable. They can sometimes develop resistance to treatments over time.
Yeah, it's like they're always one step ahead.
Exactly. But here's the thing. Early evidence suggests that ivermectin might actually be able to reverse multi-drug resistance in some cancers.
Wait, really? So it's like ivermectin is giving those cancer cells a taste of their own medicine, making them vulnerable again to the treatments they thought they'd outsmarted.
Yeah, you could say that. But, it's important to be cautious and not get ahead of ourselves. We need a lot more research to confirm these findings and to fully understand the potential of ivermectin in cancer treatment.
Yeah, it's important to stay grounded, but it's also okay to be optimistic.
Right. Absolutely. There are definitely a lot of promising possibilities here, but there are still a lot of unknowns as well.
So what kind of research is needed to move this field forward?
Well, one of the biggest needs is for large-scale clinical trials. We need to see how ivermectin actually performs in human cancer patients, not just in the lab or in animal models. These trials will help us determine the safety and effectiveness of ivermectin in real-world settings.
Right, that's about taking all this exciting lab research and translating it into treatments that can actually help people.
Exactly. And those trials need to be carefully designed to answer specific questions about dosages, side effects, long-term outcomes, and how ivermectin interacts with other treatments.
It sounds like there's still a lot of work to be done, but it also sounds like there are some potentially groundbreaking breakthroughs on the horizon.
Absolutely. It's a really fascinating field with the potential to make a real difference in the lives of people facing cancer. And we're really just at the beginning of this journey of discovery.
Well, I'm really glad we had this chance to, to delve into the research on ivermectin and its potential in cancer treatment.
Me too. It's important to stay informed about these emerging areas of research.
Yeah, absolutely. And before we wrap up our deep dive, I just want to remind everyone again that this was purely for informational purposes, okay? This is not a substitute for professional medical advice.
Right. If you have any concerns about your health or potential treatment options, always talk to a qualified healthcare professional. They are your best resource for personalized guidance.
And if you found this deep dive into the world of ivermectin and cancer research fascinating, be sure to subscribe to this channel, Science Research Explained, for more explorations of cutting-edge scientific topics. We're always diving deep into the latest discoveries and breakthroughs that are shaping our world. So, until next time, stay curious, stay informed, and keep on exploring the amazing world of science.
See you next time.